a world that walks the line. There's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a rule. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie, making power for days. Don't listen to a word that the straight no says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma bolts a mile long. Sheila on the video making tone truck with prongs. Bernie breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Builds. What's up, Joe?
What's going on, Nathan? Hello, everybody. Happy Friday.
Hey, I just want to shout out real quick to John Bigman out there. He says his my brother-in-law is losing the fight with diabetes, man. The kidneys are giving out. Hey, prayers to him, man. Hopefully he pulls through and gets through this whole thing. I know it looks grim, but best wishes to you, man.
Yeah, right on. Prayers with you, John, and your family. And wish them the best. Sometimes good things happen.
Yeah. So, what's up, Lightspeed, man? Hey, I want to give you an update, Joe, before we get into everything. Let me see if I can't pull this up the correct way. It's just not going to give it to me. I just want to say Lightspeed's working on some stuff, man, and he's showing some stuff totally awesome.
Oh, yeah.
There we
He's
go.
been sharing it was sharing some stuff with me, too, and that's really awesome progress.
Yeah, he's got all kind of sensors on that thing, man. He hooked it up to a computer program, and it gives you all the readouts of everything immediately. Dude, I'm so excited for this. This is what I've been waiting for.
That's real deal lab equipment, is what that is. So yeah, that's going to take this. The unfortunate thing about the stuff that we do here is that it seems like a lot of times the ballpoints of it all come down to data.
Yeah.
And accurate data collection and monitoring exactly what is going on and being able to do the experiments and be able to have the good stuff, so to speak, on all the testing. That's going to be what shakes the earth, because then it becomes indisputable.
Yeah, I 100% agree with that. And I love all the stuff that he's putting out on the computer program and everything, man. I'm just blown away. This, because we're going to be able to run the RAV in this. We're going to be able to run the Gravity Flyer in this. I mean, any other device, for instance, Mike's Pulse Motor, his Renegade, we're going to be running this, the Bedini. Anything when we want to see a field, a spike, or anything like that, what is it doing? Every bit of data collection is there. That's awesome.
Well, and then the most important aspect of it is, being right and being able to prove it feels good, and that's nice and all. Don't get me wrong, but being able to know exactly what's going on allows you to also change variables and control what's going on, and that way, you could make little tiny changes and have the result of it just not only be tuned up and tighter and better, and you could see it, but also possibly change the outcome altogether. And that's the evolution of it, and that's amazing. And yeah, shout out to Lightspeed on that and everything that we've been discussing lately. He has a really attuned mind, for the higher understandings of these things.
I completely agree. I think one of the cool thing was, like you said, you can tune it, but he made a program, Joe, that basically we put in how everything works. And it basically, he said he went from about 30% of it working properly to 90-some% of it working properly. So now it's time to challenge that and put in all the data and see if we can't use that program to self-correct our direction. So maybe we got some kind of a field alignment wrong or something like that. If it shows us the direction to correct it, it's like our own personal AI of correction in this whole process. But like you said, it gives us a small little details that we're not seeing. Like, do we need to move it a meter apart? You know what I mean? Or is it an
Mhm.
inch? Whatever it is, now we're going to be able to see that, and we'll see it in real time. And then we're going to find out what happens when you get two fields too close. Can we compress them? Do they not compress? Do they work together, or they work against each other? That's that's kind of cool because when we deal in the fields themselves, and how do I say this? How they actually build out. The idea is if you compress them, that they move faster. Okay, in their different direction they're going in. Now we're going to say, hey, is that absolutely true or not? And that's the way AI describes it. That's the way I describe coupling. Or am I right or am I wrong? And I don't care what the answer is. I just want it to be proven and seen.
Understood. I mean, now when you define coupling, and what's interesting is something that led to our topic of conversation today, right?
Absolutely.
Which is, I agree with you as to what coupling is. I think that that's the observable effect. And whenever we talk about fields and different frequencies and just energy in general, like, yeah, that's what's observable. But what does that actually mean? Right? Well, so a wave of what? A field of what? Coupling with what? And, you know, we say the ether, but what is that? And, Nathan and I thought maybe there was a disagreement, right? As to, well, what is that? Well, the fact is that it's not a disagreement at all per se, but I think that it goes deeper. That's worth understanding, and I think it's just an interesting talking point, from the two different viewpoints of it. So I'm looking forward to that.
Yeah, well, I bring it from the viewpoint of I do the experiments, I see the energy for as much as you can actually see of it, I should say. And I have a feeling of where it's going and how to manipulate it, right? And then Joe comes from this perspective outside of that, and he shows. Well, go ahead and say it, Joe.
Well, I mean, I see it more as a pressure between two systems that are part of one another. That's what I see it as. So there's our system, let's say, and I'm going to be consistent. I'm going to have integrity here. I'm going to say a dimensional relationship.
Okay.
So what I believe is that there's a dimensional relationship with us and a greater dimension, and that greater dimension permeates us. Okay, and we are a part of it, and it makes us up. Okay, and the fact that we exist at all is a pressure on the higher dimension, and with that pressure that exists, there is an inflow, an exchange between the matter, okay, and the forces that make up this other dimension, right? And those are higher dimensional forces, they're energies. And this is where all of the energy that we perceive in this dimension originates from. And it's where things go quantumly, right? And the barrier of this dimension and where it meets this threshold, okay, and that pressure, okay, is the energy exchange and is the perturbational, of the ether in general. It is the disturbance of the ether in general. That's the mechanism of the energy in the first place. And then when it goes out, and once it's in our in our um, dimension, so to speak, well, it goes through its state of diffusion till it just kind of drops off below Planck's distance, and then ends up going back to that upper dimensional that we would see as um, a potential at that point. It's also
Okay.
where like wave cancellation ends up.
So let's define dimension a little bit. Okay. Is a person a dimension? Is outside that person a different dimension? Is the earth a dimension? Is the space a dimension? How do we define a dimension?
Well, if you look at it through geometry, right? Like all those things tend to be true, but also false depending on how you're using it. Okay. So
Okay.
the zero dimension would be basically a point. Okay. One dimension isn't created until 2 points are in relationship. That's what gives anything its dimension, is the relationship. And that's critical to understand because it's a dimension between it's the relationship between points which defines what something is dimensionally. Okay. So you have these 2 points, that's one dimension. And now if you double that up and you have, you know, or you bring another point into the equation, now all of a sudden you have a surface. So if you bring one more point in, you have a triangle. If you bring two points in, you have a square, right? But it's a plane, it's a flat surface. It's a 4 dimensions, you double that up, and
So you're
then
you're you're defining dimension as a geometry equation.
it is a geometry equation, exactly.
Okay, but I was
So
going to a different meaning of dimension. Do you see like our physical being that we have our own energy system as a dimension versus the earth itself as a energy system as a dimension? Or is it just a geometry equation?
well, it's interlapping. Okay, so let's bring it back into fields then.
Okay.
It's basically like overlapping fields. So you yourself as an individual entity, can be broken down into all your points of dimension, upper and
Okay.
lower. Um, and you are in a sandbox with other dimensionally relevant things that you experience. Um, we experience this three-dimensionally as proximity relationship, right? So if you have objects in your room, for instance, well, the table is hard, right? And that's how you experience it, and the table is in the room. Uh, if you're aware of the table's existence, you have a relationship with it. If you observe it, if you know of it, you see, and there's different layers of these overlapping relationships that exist, and we experience it most of the time as a proximity based relationship where direct physical contact, okay, could yield an effect. That's how we see it dimensionally. Now, when you start to step up in dimension, it gets a little stranger and weirder because your relationships change. Okay. Because distance is no longer exactly the same either, because you are part of a whole greater sum, the same as your relationship due to the desk is due to proximity. Well, all of us are on Earth, right? So all of us have this common relationship with it, amongst this large object. So you could escape the desk, but the earth is the common denominator between everybody here. Um, but upper dimensionally, that becomes less relevant.
So,
Um,
real quick, I want to give a shout out to Darren. Thank you for the sticker, man. Awesome. I really do appreciate it, brother.
right on, man. Darren always in the giving mood. We appreciate that.
So, okay, just help me out here. Is the dimension defined by the energy state or the geometry state or both?
Well, both, because you see, matter does exist upper dimensionally. It just doesn't exist contextually the same. And the reason is the same as a relationship that we can all be familiar with, which is why, you know, we could experience other matter things with matter, or we could experience how energies come into our, um, and interact with our environment. Okay, but we know that we're made up of, for instance, cells, and those cells are made up of subcells, and those subcells are made up of compounds, and those compounds are made up of molecules, and those molecules are made up of fundamental particles. You see, and that's kind of what we are. You know, if you were to dimensionally look at it from above. we're there, and there's parts of it, and it's all making up parts of a greater whole that we do not observe. Okay, and the same as if you were an upper entity. Okay, um, interacting with these subparticles would be a different experience, right? Than it would be if you're interacting it on the same plane in which it derives.
I'm
So
just,
that
I guess I'm looking for something a little different, Joe. Um, like they say, if you deal with string theory, it has what 12 dimensions or 11 dimensions, something like that, right? Um, and I just didn't know if that was geometry based that they came up with that dimension. When you say fourth dimension, you say, okay, we're looking at the RAV and we're looking at the fourth dimension, which is basically the what people would say the camera effect, but we know it's not. So you're saying that's a fourth dimensional object. I'm trying to get a good perspective on what the dimension is. Is it a universal term, or are we talking about individual things based on what we're talking about at that time? Do you follow what I'm trying to say?
I do. Um, it's is it physical? I mean, generally not. Not in the sense that we typically would say something's physical. Now, when something is upper dimensional and it's crossing into your plane, even if you were to experience it as a 3D object, okay, you're still going to see it for sort of what it is. So that would sort of be like an example, like a stereotypical ghost, right? Like you would see a ghostly form, but it wouldn't be physical in that regard, and it wouldn't play by the same rules that were used to, because it is not natively derived of here. Okay, and that's actually the same with all energy. See, we're just used to how we experience energy in our dimension. Okay, but it does weird stuff that we, like to either explain heretically or sweep under the rug or call it mysterious, right? But the fact is, it's not that mysterious. You're only just seeing a part of it.
Okay, so we agree that a ghost would be a different dimension. Okay, but would that just mean that it's in a different energy state than what we're used to seeing? Like we know it's there, we can see it's there, we can't interact with it because the energy state doesn't put enough. How do I say this? Put enough energy to make a mass object that we're used to seeing. Would that be fair?
It is. And the other way to kind of look at it too is what I said before about it being pressure, right? So it's like it's not only surrounding us, right? It also permeates us. So this pressure is omnipresent as far as we're concerned. Okay. Um, and as long as something's there, there's some kind of pressure usually.
Mhm.
And the result of that is what we would experience as energy. All right. Now, the idea of it though is, and I'm kind of losing my point. I'm sorry, because like it was what I was about to say was really important, but I forget. The idea here is that yeah, it is energy. That's on the other side, and that's what comes over. That's why disturbing the ether creates energy. And how do you disturb the ether? You either disturb the ether one of a few ways: with matter, okay, which is an etheric disturbance in the first place by nature, okay, or with higher concentration of energy. Now, what what our universe does naturally and what we do as humans, okay? These matter relationships, once the energy is exchanged, comes into our dimension and interacts with the matter, well, it starts to accumulate, right? And disperse. So we know that it goes into states of diffusion and then also accumulates in certain places. Now, when the accumulation reaches a certain point beyond the ambient threshold, okay, now the energy itself can act as a disturbance of the ether. If you start to project it, like, like a radio signal, for instance, you put a radio signal into space. Okay. Well, it's traversing, and it's traversing in our dimension, except it's not manifest. Okay, but the whole entire way that it's going, it's literally rippling the fabric the entire way that it's going. And, there could be a signature from that ripple. Now, once it's intercepted on the other side and it interacts with matter again, bang, then it's manifest again. You see, because it became above the ambient. So as soon as it becomes above the ambient, or the threshold, I should say, I shouldn't say necessarily the ambient, the threshold, right? Then bang, it's manifest. But what is the threshold? Well, the threshold is the Planck scale. And that's been the point all along.
Okay, hold on. I don't want to get too far into it yet.
Yep.
I just try to observe things. So we have an energy state. We have an energy state accumulation to make mass. Okay. And then you brought up the Planck scale. So is that a next step in it?
Well, the Planck scale is the defining factor of the dimensional threshold for us. So anytime something ends up dropping off of that Planck scale in either direction, okay, it no longer is coupled with the environment. And that threshold exists because that's the point where the phase change between the dimensional planes exists. Because you had made the claim earlier, right? You said you control the ether with frequency and resonance. I said that's interesting, okay, because it's not true. Okay, it is true, but it's not the control mechanism. Okay, it's actually the result of, right? So it's the initial pressure on the ether that is the cause of the frequency, and the frequency being in tune with other frequency is the cause of resonance, leading to amplification. Now, if you have enough of this amplification, what happens? You may press closer to the threshold of Planck scale in the higher direction. See, we think of Planck scale most of the time as the lower direction. With if something is still, then or close to still, you've fallen off the Planck scale. If something's super duper 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 small, well, you've fallen off the Planck scale. But what happens when something's, the opposite, in such a high state of excitation that it moves so fast that time is irrelevant to it, is the same as being still. And the observable idea to get your head around it would be one of those like Chinese toys where it's LED lights and you program it, right? Well, all it is flashing lights on attached to a thing that you could swing it around.
Mm-hmm.
Well, if you start to swing it around, you'll start to see it go. Now, if you turn all the lights off and you're swinging it really, really fast, you see the whole entire picture as if it's a solid object that is dimensionally superior, okay, to that which it is. You see the difference? Now, when you start moving something at that type of rate, okay, it becomes dimensionally superior. So it becomes inside and out at the same time because its motion is so rapid that it becomes upper dimensional, and it will fall off that scale as far as that additional metric is concerned. And 3D, it may or may not disappear. Okay, you may just observe it at that point as a still 3D object.
Okay, so hang on real quick. I want to define the Planck scale. Okay.
Mm-hmm.
When you say Planck scale, okay, from my understanding, is they were looking for a constant, and they thought all the stuff in the universe worked at a constant. What they found was it didn't work at a constant, and when it get into different states of energy, it then amplified, and they thought it would go to infinity. Okay, My understanding is once they reached off of the Planck scale, the energy was amplified. Now, is it in the Planck scale that it's amplified, or is it outside the Planck scale that it's amplified?
It, I think that's where it comes into the dimensional exchange aspect of it. So
Right,
the
but
observable
it's
effect
on
is
one side or the other.
no. So the amplification is here as our observable, but the reality of it is that it's letting a greater amount of that in. So it has changed the exchange rate.
So hold on. I just want to get this right. In physics, they have a constant, right? And they want to say everything's a universal constant, right? And then Max Planck came up with the idea of the Planck scale where things are not in the universal constant, right? So my understanding, okay, is when you get into the Planck scale, you get into something that gets you into superconductivity where the energy rate is much higher. You know what I mean? Yes, it's letting in more stuff, but what does that
Love it.
mean? It basically mean that you took in stuff like radiation, you took in entropy, you took in everything that looks dormant in the system, and it's now working, which means you're beyond the constant in the universe.
Okay, so I love what you just said because it proves the whole thing out, right?
Okay, go ahead.
So the idea here is that it's a pressure. Well, what are the conditions in which pressure is created as a differential? And that differential means that there's a resistance. So you have something that wants to fully permeate, but is being pushed back. That creates a pressure. Okay. When you have superconductivity, you've done away with that resistance. You have a free flow and exchange. The
That
proof is right there, and that's the point. you know, and that's exactly what it is and what it's always been. So when you have this free flow and exchange, and then all of a sudden the physics starts acting weird, it's not because you've changed anything physically. It's because dimensionally you've decoupled the energy exchange relevance between the matter itself. And now your 3D observables are playing by upper dimensional rules because you're bringing another dimension into our dimension to play by a different set of rules.
okay, so just as far as we are, I'm taking dimension as being a higher or lower energy state on a scale. Is that wrong, or it
I
has to do
mean,
with geometry as well? But I'm saying,
there's a geometric aspect to it that's definitely relevant, but it is a higher energy state, absolutely.
okay, and I think we probably both agree on this. Based on the geometry, you're getting a higher energy state. That's the trigger for it.
Well, the geometry is the determining factor of the pressure. Okay, and
Yes.
what's doing what. Now, again, because we're permeated by the fourth dimension, we have energy that's we all live, okay, our lives literally in the fourth dimension, if you want to think about it, on the ether, within the ether, on this boundary, under the pressure. Okay, that is the cause of the slowdown of time dilation. That is the cause of time.
Mhm.
Okay, so everything we experience, we are always under this pressure. Now, I mean, like any pressure, though, if you could relieve it, right? How do you relieve the pressure? Right. Well, you relieve the pressure by becoming more zero doubt with the ambient of what's pressing in. Okay, so if you equalize with what's pressing in, well, then the pressure isn't there anymore. You're just so what does that mean? Well, I mean, that's what's interesting. That means you're decoupled. Okay. You're decoupled with the ambient atmosphere or the ambient environment, I should say, of everything else still experiencing pressure. And that comes
Okay,
through lowering resistance.
could that be on both sides? So just hear me out here. If you decouple from the environment, you don't feel the pressure of it. If you couple with the environment, you can now move within it without impedance. So, which one are we looking for? You know what I mean? So, if we want to do a, say, anti gravity, we have to couple with the environment to move within it freely. If we want to decouple with the environment, we're just building a bubble like a kid, right? And it decouples and flies wherever it wants to. Okay? But if we want to move within it, we have to couple with it. Does that make sense?
It doesn't. No, because here's the thing. There's two aspects of it. Okay. And it's whichever you want to subscribe to, I suppose. Okay. The first aspect of it is that once you've decoupled, okay, your perspective experience, okay, no longer is that of you in some kind of anti-gravity craft or something. Okay, the perspective of you is as an observer, okay, it changes dynamically, and the ability of that craft to actually go here or there, depending on how it's controlled and whatnot, would be significantly different than anything that we're generally familiar with under those particular circumstances. Okay, that runs into time travel type wormhole stuff, because basically it's at a point where it could create itself a wormhole anywhere it wants to go just by going. All right, but without touching that aspect of it, let's just deal with something else, which is rather than just totally becoming totally ambient, okay, with it, you break the threshold of mass, okay, to achieve a neutral buoyancy with the environment and not the ether. Okay, now, if you achieve that neutral buoyancy by pushing everything around you through eddy currents, right? You would have to have an electrostatic that you revector, in my opinion, okay, to in a scalar form, okay, it would take in and disperse energy inversely, okay, and what that would do is push everything out. So when something's pulling in, and then it gets to a certain point and it pushes out, that creates a bubble around what you're doing and is moving out all of your environment from you. Now, all of a sudden, if you do that just enough, okay, that you're not necessarily at the Planck scale, but it's enough to defeat the force that's working against you. Now you have neutral buoyancy. Now, here's what's interesting about that. All you have to do in order to steer and direct yourself under those circumstances, okay, is to change your center of gravity. Because now you have to think about this as a hydrodynamic problem, like a surfboard, or a skateboard or whatever you want to think of. Surfboard's a better example. So you have the environment around you skimming and moving away from you, right? Like this. Well, now all you got to do, you change your center of gravity, the relationship changes, and now your trajectory has changed. And that's it. Like it becomes skirting through. And that's exactly the motion that you see when you see weird UFO videos and stuff, and something will go like whoop whoop, and then it'll be like this, because it's treating it as if it's a fluid environment, because as far as that craft is concerned, it is.
Okay. I'm going to disagree a little bit. And it's because the decoupling is 100% right. Okay? But that's only a gravity well. Gravity well is not direction. It has no movement to it. You're dead in the water. You're anti-gravity. You have no weight, but you're going nowhere. See, I think you have to couple with the environment to move. You say it's just as simple as, changing the direction. I think the changing in the direction changes where the energy and the flow of the energy you're riding on. So you have to recouple with the environment to ride on it. It's not necessarily completely different than yours, but
No, it's not.
It's like a nuance.
No, it is a nuance, but what I was saying is actually nuance in there, because it lied within what I said about it being a breaking a neutral threshold with the environment, as opposed to joining an totally out of phase state. Okay, and that means that it's never fully decoupled at all. And the way that it stays coupled, okay, is by what I was describing as a one-way type valve. Okay. Now, when you create these eddy currents that are going to, you know, take in, but then push out and take in and push out like that, and it's doing that top and bottom, well, you still have energy that is being off put, you know, from your craft in this case, we'll call it, right? Um, and that energy is allowed to go into a diffuse state with the environment somewhat. You see, it may be somewhat contained in its flow patterns, but it still goes into a diffuse state into the environment, making it coupled. The difference is that it's keeping the environment away from the craft. And that's the difference. You see, as long as the environment's away from the craft and none of the environment's getting into the craft, then it's not subject, in my opinion, okay, to that which would make that relationship exist. Okay, but the relationship is maintained through a one-sided diffusion, which means
not go
then
any further just yet because I just want to clarify. So we're on the same page here. I think we're creating a bubble to go outside the environment. Okay, that's no longer controlled by the environment. Is that correct? We're decoupling.
correct. It's you know, it's directly separating the craft, if you want to call it that, and the environment.
Okay,
right.
So that's because I always get in arguments with people about this. They think anti-gravity is one motion, and it's not.
Nope.
It's a decoupling, which is a gravity well, which means that your gravity is greater than the environment around you. Therefore, you can control it, which means that the gravity itself is not penetrating the craft itself. Like you said, it's going around it. So if we just saw it as a waterfall, it'd go around it. Okay?
That's exactly it. Yep.
Okay, so we're good on that point. The second one was you said it rides it like a wave or something like that, and I can completely see that if you see energies and flows and directions and stuff, and then you're just like a surfboard catching the wave and you're riding it to the direction you want to. I think it's a little more of you're creating an energy imbalance inside, and you're following that imbalance. You know what I mean?
All right, hold tight. There's something super sneaky that I said before, and I don't know how many people picked up on it. Okay. But I said all you have to do to steer your craft is change your what? Center of gravity. But wait a second, you're in a floating craft. In an anti-gravity craft. That's because you didn't defeat gravity. See? You defeated ambient gravitational forces. Okay. The relationship of energy exchange, therefore gravity, still exists locally. Okay. So your craft still has gravity. Therefore, it still has a center of gravity. By having your energy source, okay, centric, all right, is the new center of gravity, because as we all know, it all pulls inward toward the highest energy density, right? That's how it works. Isn't that what we're doing right now, standing on Earth? Isn't it right? So this is how that goes. Now, what does that mean? Well, that means that if all you do is shift that, now your center of gravity in the craft is changed. That changes the field dynamics, creates a bias, and therefore, like, you know, squeezing something and it shoots out, like, same difference. You know, like, but it's shooting yourself, but perpetually.
It's an energy state. So if you said wind was coming at you and you took a plate and you moved it in an angle, you get a higher energy state here at the buildup than you would here at the end, right? Because it's deflecting it. But that's what you're saying, right? Is that you create the imbalance in the energy state in order for it to flow through the river, or however you want to say it.
Well, right. Once you create the asymmetry, all of a sudden you create a pressure.
Yes.
Okay. And then that pressure allows you to be propelled, but because you're also in a bubble, because you're displacing gravity, there's no resistance. So there's nothing holding you back. So that little tiny bit of pressure make you go real quick, real fast. There's also no forces to be acting against you. So there's no inertial field because there's nothing like accelerating isn't changing anything, and decelerating isn't changing anything. So you could literally blast off and stop, and it would be effectively the same because you're in relationship with the gravity of the craft.
Yeah. All right, so we're in pretty much agreement on this. Okay.
Oh yeah,
Just
that's what I've been saying since day one. But it's like I said, it's this pressure thing that's weird, and it's I'll just keep on asking that question until you could feel it in your soul. Pressure of fucking what? Exactly.
you're pressure. Well, no, it's not hard. You're pressurizing the energy. I mean, that's really what it is. It. You think about it. You got the world, right, and you got this outer shell, right? What is it? It's a plasma state, but that's just pressure and energy. It's a gradient, and then we get below it and above it. It acts as a sheath layer. We can clearly see it in plasma physics as it acts that same way. Okay, and then we know that there's the energy gradients in between it, and then it'll build out consistently the same way in spherical structures. That's not hard to figure out, okay? And yes, there's pressure on it at all times, but that's how the energy gets amplified. You see, the ether just, like I said, I think it's a magnetodielectric effect. It's basically not static electricity. And I hate when people say it because it's the wrong word, okay? You're creating a high potential of energy, but it's not static. Okay, static comes from a physical rubbing or something like that. That's the state that it comes in, and it creates an electrical value added to a potential state. So if you take the energy potential on one side and it's pure, you know what I mean, potential, and then you get to the other side and it's pure magnetics, we're always in this flux between the two. And that's the whole idea is where we're at depends on what's going on, okay? On the pressure increase to it, right? It's like in a battery, you take the dielectric and you force it together. What happens? The magnetic field pops out. But then if you rotate a dielectric, what happens? The magnetic state pops out again, okay? That's what we're doing. We're compressing things in an environmental condition. Based on 360 degrees of environmental condition, you're going to get that pressure gradient. You're going to get the magnetodielectric effect to appear, which means it's going to form out in zones, and it's going to go into the sheath zones that's magnetic. Then it's going to go into your dielectric that's non-magnetic, okay? That feels non-magnetic, okay? And we go in there and there's different gradients and they'll continue to burst out just like that. We see it all day long in plasma physics.
All right, so hold on, check this out. Tie it to Rav real quick.
How does a RAV work?
I'm not holding tie it to Rav real quick. Right. So you have everything that we just discussed. Okay. You have these cross flow, exchange, eddy currents, gives the rotation, gives the compression, gives the density, gives okay, that's what we observe on this side. But now we've observed other things too. And as far as I know, the video I sent you a couple weeks ago, I'm gonna make you dig it out, okay, is what shows it. Okay. And the idea here is that if you create a zero resistance situation, okay, and you know that it's an energy exchange or it's an exchange, okay, you create zero resistance. That means that that's an open door two ways, okay. That means that we're bringing energy out of, freely, okay, but that means things also go in freely too. That's what an exchange is, right? So, well, how would you find the evidence of something going in freely, something being attracted in? Well, if you look at the video of the crystal that I showed you, okay, what you end up seeing is a large blast ionization event, okay, where there's ionized particles that are popping up. And because everything was in such a high charge state, and that resistance was super low, all those particles, literally 360 degrees, came into the RAV. You see, because those charged particles were part of that exchange at that point. They were sucked in to be exchanged for energy.
Okay.
Super freaking neat when you think about it that way, isn't it? Because it's a two-way door.
Okay.
It's not a check valve, right? So that means that the RAV has huge gravity from the outside perspective, from our observable, but realistically, in onto itself, as far as it is concerned, it doesn't have gravity.
I, okay. How do I say this? The Rav shows something special, and I go ahead and say it before we put the episode out, just so we understand it. Those little dots that you see in there, okay, let's just understand what's going on in there. You're basically, those are just atoms that are sitting around, and then they're compressed together. And the reason that it's working is it's coupling the energy between them. And it creates a resonance between each atom, okay, that creates a coupling. It's no different than Tesla coils when you couple them. You're just coupling the energy between it, but what does it do? What does it do? It creates the ether state. The ether state is without all the magnetism in it. Okay, it's combining it. It's not electrostatic. Okay, just get that out of your head. Not electrostatic at all, but it's combining them together. Okay, and when it combines them together in that energy state, it creates a magnetic state. Okay, that's where the magnetism comes in, and it forces them to push out a little bit. Okay, but that's what happens in every time it forms. I've seen it constantly again and again and again. But that's
Mm-hmm.
how atoms forms. That's how atoms work as well. We're
Yeah.
creating an atomic state in order to create gravity. That's what it is, and that's how it shows. And then as soon as it does that, it works just like out there in the solar system. It's doing the exact same thing. So as you see them coming in, they're sitting in a correct distance from each other because as they pulled in, okay, they pushed out based on a magnetic field that goes on in between them. And then they form a layer that goes around it, which is the sheath layer, okay? But then they'll continue to do that out there. Even though you can't see the little balls anymore, they're continuing to do the same thing out there, okay? They're bringing in the atoms, okay? There's an exchange, there's a leakage that goes on to the next level. We see the states grow. What is gravity? It is that. It is that forms the atom itself. That is the exact portion of what gravity is. Now, why is the RAV not highly gravitational right now? Because there's not enough energy in it. Once there's enough energy in it, say goodnight, man. It's going to be a huge amount of gravity. Okay? In the current state, there's not enough energy into it. And the energy is only going to get there in compression, and we're not compressing that RAV at all. We're letting it free flow in the environment. Once we start to compress, we start to pull some energy out. Okay? That's when you start to feel it. That's when things become gravitational. However, the problem with mass exists. Math doesn't create more gravity. That's the problem. It uses the gravity. When you want to create more gravity, it's like Saturn or Jupiter, okay? You're letting it out, okay? You're letting it express itself. It has a higher gravitational field. It is bigger, okay? But once you add mass, it reduces the gravitation of an item completely, okay? That's the problem, is when they start talking about, oh, you're just rotating mass, it creates a big G, okay? Well, that's wrong, okay? You forgot this whole state that you had to build of the atomic level of all of this building to get there because it's not a constant like physics says, it's emergent. It's emergent based on the state that you put it in.
So I agree with that, by the way. I want to address a couple comments if we can,
Yeah,
because
go for it.
there's some good ones and there's a handful of them.
Go for
So
it.
first of all, Wahoo says that if you leave the RAV on for a long period of time, it will suck your life force energy. I disagree with that because see, the type of gravitation, okay, or the type of suck that the RAV has, okay, it doesn't want the energy, it's giving energy. You see, this is the exchange. It wants matter, okay, but it can't just take matter. It has to take matter in an energy state that's in an equilibrium of itself, decoupled, high charged matter. Now, that's why the example I just gave with the charged particles that came off and sucked in, that's why they were able to suck in. You see, if they were just in a more ambient state, and not a glowing ionized state. They would never have sucked in because they would not have been, you know, of that type of equilibrium. They were only attracted because they were part of it, you know, and that's why when the Rav goes and breaks down surfaces and different, you know, materials into more fundamental particles, it has to break it down like that, to break down that matter, to take the matter at its smallest bits is the only way to get it into the high charge state enough, okay, for it to be at an equilibrium in those contexts. So it's actually taking that, and that's what allows for the transmutation type properties, okay, because, you know, it has this low to zero resistance situation, it take matter in, but allow it to come back changed and denser, you know, because of the energy levels and the collisions that are occurring in this exchange. And that's exactly the idea. It doesn't want the energy. It wants the energy. It wants to turn the matter into energy and have it go into a diffuse state of relaxation to return back to the, that's what it wants. That's the whole reason that all this game exists, of matter
Yeah,
and energy
but
and all this shit.
but that's the thing. What it's doing though is it's taking the energy state that it's in, it's allowing it to go like in a mush state, okay? And then it's changing the frequency of it in order to change the magnetodielectric in that, okay? Which then it reforms on the surface, okay? And it'll pick up whatever it needs, whether it's an electron, a proton, whatever, you know what I mean? That's the frequency difference in it. That's why they have to do that. That's why the frequency is a control factor. It's a it's a way to calculate how things go. So when we deal with mercury experiments, okay, Merkabah's been doing this a lot. He's sending me stuff all the time, and he's saying the same thing. Once you change the resonance within it, you change the mercury state of being, which it'll transform it into different elements, okay? Because it's already in that state. It's already broken down. It's in that not quite a metal, not quite a liquid state. Therefore, it's so much easier to change it, and you're
Mhm,
changing it based on the frequency. That's why I say it's a
mhm,
controlling factor of how transmutation works, even though we don't see it in plasma a lot, like the way we see it. But the way it's happening is you can see it in the colors, because every time it changes colors, you're changing the frequency state of it, right? You're changing that wave. Once you change that wave, you're looking at it and it goes, oh my God, we got a different mutated element. It's pulling in what it needs from everything else. It's rearranging it. It doesn't see the difference between the electron in iron and copper. It just
I don't
doesn't.
know.
It
Nope.
sees it as an electron. And how many do I need? And how many proton? You get what I'm saying? So
Yep.
that's why it can transmutate.
Absolutely. And right, it just ends up being a bunch of Lego bricks at the end of the day. Like,
Yeah,
you know,
it really
right.
does.
You could sit there and build whatever you want out of Legos and be like, it's a this, it's a that. Cool. Once you take all the bits apart, you could make it into something else and be like, is it still that? No. Okay. That's because it was Legos all along. It was, you were playing with the bits and pieces. Um,
Yeah.
in fact, what you were just saying, I mean, Sean's most recent video that he sent me, which I slowed down,
I'll
okay,
put down.
told the story better than any other example, even though we've seen it and heard it before. So he sent a video of, this is the original video he sent me, okay? Then we'll show you the slowed down one. So this is of a self-nucleating cathode. Okay, now we've explained how this works before. There's the anode cathode relationship. Okay, they're too far apart. Okay, to have a clean connection, but they want to make that connection, so they have that same asymmetric exchange. That asymmetric exchange has beat frequencies, okay, and different alternating and evolving frequencies that are occurring, okay. And what ends up happening is it restructures the metal of the cathode, okay. And once that restructuring occurs, it does so in that equilibrium state, okay. But not, between the two, the difference between the two. And once that occurs, it then has a surface, okay, for the RAV to stabilize and create. And that's more or less how that occurs. Now, when I slowed this down, there's a lot of interesting stuff. One thing I want you to see real quick is you see this green rarefied plasma. Okay. That's oxygen plasma in a highly rarefied state. All right. And if you notice, it's separate of the nitrogen and the hydrogen plasma that's also in this. You'll see it go through the bands of frequency, though. Okay. And depending on what band of frequency it's going through, will be which gas is dominant in its excitation. All right. And when it forms, you'll see the green, okay, separate. But when the RAV starts to destabilize, the frequency changes, it falls down, becomes a part of it, re-energizes it, and then re-emerges. And that's what you'll see. But that's not even what I'm trying to explain. That was a sidetrack. So the point that I'm making is that there's a song that this plasma puts out that's deterministic of the shape of the plasma and the color of the plasma, okay, as it changes from phase to phase. It reduces significantly in frequency, coming up to the structuring of the self-nucleating cathode, and reduces. And then you could hear exactly what the frequency changes are in the beat frequencies. And it literally is like talking. So if you want to play the slowed down video and put the volume on, you know, everybody could kind of hear that.
Okay. That definitely
Neat, right?
make it sound, yeah. Oh, you can hear it right there when it started creating it.
Uh-huh.
But okay, hold on. They went from random to harmony.
Uh-huh.
So
Exactly. Uh-huh.
This
It
is-
wasn't random, it was self-correcting.
Yeah. So here we hear it.
So now I ask the mystery question. You heard what happens when it falls into coherence. You heard an amplification event, and then you hear it wean off. And now it's mostly silent. Is it? Is it mostly silent? The thing is that when you open up this zero resistance situation, or very close to, you're not hearing the noise because it is that close, that it is that far in coherence, and the frequency has actually went that low or that high. Okay, in this case, it's low. It went that low that it's falling off a Planck scale all the time, falling off, you know, or very close to it. But it's past the threshold of normalcy.
Mm-hmm.
That's what's occurred. And that means that the time dilation of this is significantly different. Okay. So what's weird is that you try to get an outside measure of this thing to find out what's going on. But guess what? Can't do it from the outside because we're out of phase with the thing. So you try to look at it and get an outside measure from it, but you can't. And then you go to stick a probe in it to see what's going on inside or whatever, and it can't.
Yeah, but
Because it'll dematerialize.
I know, but it is giving you a signature. Okay, hold on. So let me pause this. Pull this out. So when it's going in, it's giving you the frequencies, right? And when they start to wrap and close it in where you can't hear it anymore, they're still present because now you can take the actual number that's going on in each one of the zones and figure out the frequency, and it gives you the harmonic, okay, of each thing, the first, second, third, fourth, and fifth, and how they build out in harmonics in it, which is, by the way, the exact same thing that ancient people tried to tell you for a long time, and we weren't listening, but now it's 100% proven that all those things are right there, right? All of them are combined in the same thing, and we're just now seeing it correctly, finally.
Mhm. That is true. You know what none of us have ever tried, and I know it's out of fear because honestly, like I thought about it and I was like, no, is we've never put anything into a wrap, and uh, if you've ever seen the thing in person, you'd probably have the same reluctancy. Funny thing is that for anybody that's like thinks that this is some kind of arc type of circumstance, well, think about it this way: I welded, right?
Oh,
Well,
hold on.
and
Real quick, let's go back to this because
yeah,
what you're just saying right there. Look, okay, let me explain this. This right here is a spark gap. Okay, when you
hmm
see all that, that's a spark gap, and I'll show you the difference right now. Once you get into this state, it's a RAV. Okay,
hmm
completely two different states of energy. Okay, the spark gap has no coherence whatsoever. It's just random. Okay, yes, it has all the right songs in it, all the right things in it, but it's just sparking over. The RAV is what takes it and makes it into the energy state that it needs to be. So if you ever heard somebody say, "Man, my system went from the temperature being 220 degrees, right, down to room temperature," why? Because they had a spark gap that turned into a RAV. And that's what was going on in their system. It brought coherence to the entire system, just like it did here. And that's exactly the state it was in. So when somebody says it's a spark gap, it's a misunderstanding of plasma physics. They don't understand it well enough to say it. They're just a fly by night. I don't get it. This just looks like it's sparking. Well, yeah, but until it builds the RAB, then it's coherence. So go ahead,
I
Joe.
totally agree. Yeah, it tries its best, and it's not always possible, but when the conditions are proper, it will fall into that correct state, self-organized state. Um, I mean, look, what I was saying before about sticking something into it, right? Like, as somebody who's welded, you know, I've never ever had any aversion to dipping a rod into into a TIG, into a TIG arc ever.
No.
But I'll tell you what, I look at this thing and I'm like, I ain't putting nothing in there. Like, something about it just says, don't do that. You know, like, it screams danger.
Huh.
Like, I don't, and the thing is I have a whole list of things that could happen in my
Yeah.
head, and none of them are good if it involves me.
Yeah. No, I'm
like
there with you.
like I'd love to see it, but none of them are good if it involves me. And I don't know to what degree of effect it would, you know what I mean? Like,
Oh, you know what? Hold on. No, I did stick something in between it to form it. So I did stick a piece of clay straight up, okay? And then I did the two, I guess it'd be two anodes in this case, right there, right? But it formed a RAV on each side of it. So it was acting, I
I get it,
guess,
right?
it was exchanging in the energy, right, between the two. That's what was happening. Well, I
Yeah.
wouldn't put my finger in there
Now,
by any
now, now
chance.
that's, by the way, that's an awesome entanglement experiment, is what that is, and that's
Yeah.
entanglement proved out because that's exactly what it is. But neither here nor there. I mean, again, something being physically inserted into the RAV, I think, is a little bit different than that. I mean, I wouldn't want to be in between the two RAVs either in that circumstance, because that'd be an interesting situation. But whatever. It is what it is. It's a curiosity that I don't care to know much about at the moment.
I just wonder if depending on what it is, what would happen. Yeah, because you're getting shocked if it's a metal object. You know that. But then,
Maybe no, maybe not though, because it could break down the conductivity of it immediately
and
because of the
just disperse
threshold.
it.
Yeah, yeah, it might dematerialize it is one of my guesses.
I'm thinking I'm getting the dematerialized portion towards me. Is
It could also decide that it's going to conduct in its in its fluid state and literally bite you in a way that you ain't never want to be bitten.
no. There's too much energy in there.
Uh-huh.
Because it's compression of energy is what you're doing when you create the wrap. So yeah, I don't want to know how much is in there.
So that's a possibility. It's a possibility you might stick it in and think that, oh, look, it melted, but it's not melted, it's just gone.
Yeah.
Where does it go? You can make an argument on one side of it and say, well, it redistributed over here, and that's where those molecules went. Or did it? Is that all of it? Can you account for all of it? Well, where's the rest? Did it break down? Did it go somewhere else? What did it do? What does that mean? Think about that. It's fucking crazy.
What it'd be interesting if you put in carbon and got out graphene. You know what I mean?
Well, we saw them trying to do that. They didn't know what they were doing, but we sure did.
Oh yeah.
Yeah.
Oh yeah, yeah. So we were watching an experiment once. This guy put in this spark, right, and he put it into a pot, and there's a bunch of coals in there or something, right? And then he's rotating this thing around, and what's happening is he's creating a rab in there in order to bring the energy in there to a higher state, in order to get the temperature up, in order to create the graphene effect out of the carbon. So yeah, we were watching that.
The carbon wasn't burning, and he had
No,
the
it
arc,
wasn't.
right? And he had the arc going, and you would see moments of RAV formation. Okay. But because of what he was doing and that he just didn't know what the means to his ends was, he just found a way and it worked. So cool. Look, this works better than what we knew. The RAV wasn't sustained. So they were able to produce graphene that way. But it was only in what they would consider large amounts, but it's still only small amounts comparatively. If you had an ongoing RAV in the thing, it would be making graphene like nobody's business. But that's not how he was going about it. And it was not burning. There was no combustion going on at all.
Nothing. It was a neat experiment, I'll say that.
It was.
It was interesting to watch.
The arc's also pulling in, charging those particles, pulling them into the reaction. So it's happening even without the RAV at that arc stage, but at such a small point that it would be negligible. That RAV will be what tears apart the molecular structure and then poops it out.
Yeah. Yeah, I was looking at this thing earlier and seeing what state we're in. I always tell you can't throw a magnet out and have it go anywhere and lift. And it's because we're in the wrong field. I mean, when you think about it, we're 100 volts per meter. We're in the dielectric. We're in the space in between the anode and cathode. We're literally in that field, right? So when they go, oh man, we're spinning magnets. Well, what happens? You get this tiny little bit of reaction to it, not much, right? And you go, well, why? Well, it's because you're in the wrong field. And you look at it and you go, well, energy is created through all different kind of materials. So what material are you using? One or two? It's not good enough.
The thing is, man, about the dielectric fields in general is the hard part about them, which is they're a component of a bigger thing, and then it's nested. Everything is nested. So it's like the dielectric field that we're in is within a greater magnetic field. And then there's a dielectric field outside of that's in a greater, and this is exactly how that plays out. It's all nested like that. It's just super strange to think about because people like to have that conversation about, well, oh, the dielectric field, but then not magnetism. Well, guess what? No dielectric field without the magnetism, none of it without the matter, and none of it without the energy exchange, and none of it without the pressure on the ether. So
Oh yeah.
that's what it comes down to.
Well,
It's just
absolutely.
super interesting.
Yeah, that's what I was trying to say. I love all the talk out there, but every time somebody goes into, I'm going to create anti gravity, I'm going to do it with magnets, I start laughing. I literally start laughing because I know that they have no idea what they're doing. They're just literally spinning magnets, which I think is fun. Don't get me wrong, I do it a lot, but I know I'm not getting anti gravity out of that. It's just not going to work. You know what I mean? It's a means to an end. So were you looking for convection out of it when you hooked it into your aluminum? You know what I mean? Were you looking for something else? You know what I mean? Were you looking for eddy currents? That's what you're looking for. The magnets are pretty much irrelevant to the field, except for that, right? They create that was just going on. Your high voltage already has the magnetism in it. You know what I mean? It's setting the parameters. So the magnets themselves, it's there for a different effect. I want to thank
Right.
Lightspeed out there. You gave 5 Old Men Builds memberships, man. Thank you very much, brother. I
Awesome.
appreciate
And
that.
congratulations to the people that get them. Make sure that you go into the members section and check out the members only videos because those are worth it in itself. That, sometimes we show stuff and then if you missed it, good luck. You're going to watch a 3-hour episode to see the one thing, or it's just put up there. So congratulations. Enjoy.
Yeah, got all Sean's electric experiments in there too, and he's got more of those coming out as well. So
Mhm.
I always put those in there. You know what I mean, and everything he sends me. If it's not published, it's in the private section. So no matter what it is, there's a lot in there, man.
Yeah. Well, hey, let's talk about magnetism for 1 second in terms of a permanent magnet. Well, why is a permanent magnet a permanent magnet? Well, that's because it's structured in a way, okay, to hold a high energy charge state, okay, in the geometry to keep an energy exchange, okay, open, that creates fluctuation with the environment, okay? So that will always be in a higher energy state in a certain configuration, okay, to more or less be greater than the ambient environment, which then gives it an attractive or repulsive force. And that's interesting to think for a second because what that means is that by creating that structure, okay, that's the greatest similarity to to the neutral resistance, okay, of the energy exchange between dimensions, like I've been kind of saying, by mimicking that type of geometry and then having energy actually in there, it actually keeps an open path through that dimensional exchange, in my opinion. Okay, so what that allows for, okay, is to create fluctuations when it's moved, right? So as we know that when you move it in relationship, it's holding this charge and it's bringing in this charge and it's in a certain sequence, and now you're moving it and creating a fluctuation. And if you bring that in with a conductor, well, then you could capture that fluctuation of the open portal that it has, so to speak. Okay. And that allows for you to, um, capture it as a current because it's causing that fluctuation, causing an excitation that's allowing it to come in through that portal. It's changing the dynamic relationship, through that motion. It's interesting to think that it all makes sense once you kind of think about it in that way.
Yeah, well, I can see that.
Yeah.
You're only pulling in energy with that stuff. You're not creating it. It's a total misunderstanding of how it works. Say creating it. Yeah,
Mhm.
that's funny.
Oh, right, right. You're giving it access. It's
Well,
and
Which brings us to a funny thing, Joe. You think about what the metals are, right? You say I got iron and I got copper, right? What does that mean? You got two frequency states going on in there, okay? That's it. Out of a possible, what, 50 that you can have, you only got two. So when you look at it on how do I say, the phase, you've got two phases of a 30 or however many you want to say are in there, right? Because semi-magnetic material becomes magnetic material once you reach past a certain threshold. So it's like you're missing so much of the picture.
Yep.
And I want to say this, the best way to say it, if I basically took the pulse motor that I built, Mike's Renegade here, right? That's right behind me. And I take that and I simply take the core out and I switch the core between different materials. You start to see them show up on the oscilloscope, and then the capacitor would tell you exactly how much you're actually making. That's the funny part. Okay. So that's in my testing, by the way, Joe, for the Renegade here. I made that core. So in the core, it's got a bunch of little rods in there. It's 3D printed plastic, so it goes in and exact distancing from each other, right? So so far I got the iron rods. Then I got aluminum rods, right? I'm working on other different ones to put in there. But what happens is on the oscilloscope, it shows it as much less, but my capacitor fills much faster. And I'm going, okay, so there's not as much resistance, and I'm filling much faster, and this thing's hauling butt around here, right? So what does that tell you? I'm in a different phase. I'm just phasing through a clock with all the different phases of energy. That's what it is. It's not a phase, a hump with a hump, a hump. It's phase and a phase and a phase and a phase. Much different. And I like the experiment because it shows you a simple understanding. We're doing it the wrong way. We're not taking energy how it wants to be told to us, okay? How it's saying, I want to be seen. We're assuming it wants this one condition and one condition only, okay? It's like saying we can only like brunettes, and that's just not fair. There's other colors out there, you know what I mean?
Yeah, some cute redheads and blondes out there.
That's what I'm saying.
I'll tell you that.
Let's start paying attention to them. Yeah.
Watch out with that for them women with that dark, almost black hair, because those ones, sometimes that's rough.
What I like about it too is like you could take pencil lead and put it in these things, man. You could take just basically crushed up material and put it in there because it's 3D printed, right? So all you're making is, you know what I mean, a core. It makes it very easy to do stuff. You could take soft iron in there and put it in there, and you could test it. You take hard iron. It gives you a different understanding of what you're actually doing.
Well, the material that you're using is the gateway that is going to be receiving what it is. So of course it's going to change the dynamic of how it's received and what you get out of it. That's why the arrangements of all these different types of metals, and stuff, just in general, are really, really important when it comes to what types of electromagnetic effects they show under normal circumstances, let alone under extreme and induced circumstances.
Oh yeah. Well, I can't wait till we freeze this sucker down, man, and put it in the freezer and ice it over, overnight, and then throw it in there and see if it changes it. You know what I mean?
Yeah, right on.
It might not be as cold as it needs to be, but see if any temperature differential would be good, and see what it does. That's why I like this experimenting, man, because I just like to freaking try everything. And because weird stuff comes out of it, and you're like, well, that didn't seem like it went that way, but it did. So let's find out why.
Yep.
So I want to see what happens if it forms a dielectric between all of the rods that are in there because they're separated. You know what I mean? So you're getting a magnetic field in there, and then what's the dielectric value as it goes in there? So if I find a material that triggers on the dielectric, will I get a heavier field that comes out of it? Would it amplify more? You know what I mean? That's kind of crazy stuff. And then, just as a personal note on that Renegade, I want to change out the light bulb because that thing is flashing and killing me. Okay. it literally is making me dizzy when I'm looking at this thing, and it's just a big white LED blasting like this. Okay, so I ordered a bulb that looks fancier, and it puts off like green lights and stuff because it's strobing. It's just driving me nuts. I got to find a way to get it to not strobe at me.
All right. So I want to ask you, it's a weird question. I don't even
Okay.
know how I'm going to phrase it because it is a weird question. Okay. But under the circumstances that we're discussing, okay, what element or material, okay, do you think um, brings in the most energetic potential
Mm.
of exchange? Like if you were to consider everything to have an exchange rate, okay, what would you consider the highest exchange rate value to be? Like, would it be density? Would it be mass? Would it be what? What would it be?
Honestly, I think it's mercury.
Okay.
And, and I'll say it in this way because it's easier to hit a superconductive streak with it with mercury than it is any other metal. Like if I go to cobalt, right, I still have to get it cold. I mean, super cold, but mercury's liquid at room temperature, so it's going to give it a whole different thing, right? I think those metals that like bismuth that melt out at a very small temperature, I think those are the highest reactive metals that we have, which would make a much better core. That's my opinion. My thought, anyway.
Now, my answer is a little strange because I agree with all those things because of the application. Okay. But I think that the answer is energy density potential. Okay. Energy density potential, meaning that what's the one thing that you can fit the most of in a small area that would have the most energy potential? That's hydrogen every time. You see, and that's what I think is interesting about it. You
Which would
know,
you say? Just like John said here,
hydrogen.
hydrogen.
Yeah.
So just a gas put in there, a gas tube of
Well,
hydrogen.
you're thinking of hydrogen as gas, but hydrogen is not only a gas.
Yeah,
Hydrogen, any state of matter that it is compressed to.
yeah.
But there's circumstances in which it, well, you can't compress hydrogen, it'll combust. Oh, I mean, that's under certain circumstances. But no, that's not abundantly true. Can't combust with no oxygen. Can't
Hmm.
release with in a direct energy state that it'll turn to plasma. But you could get it into a plasma state and compress it all you want because then it doesn't have its elemental property. And the more you compress that, well, it'll fall into different crystal structures. There's liquid and solid hydrogen on planets in our solar system.
So hold on. So a little different, but I'll throw it out there. Say if we ionize the water, we run water through the core of it that's ionized. Would that bring a higher state of energy then? Or say we did the effect and we started to remove the water. I mean, excuse me, the oxygen from the hydrogen. You get the two hydrogens and remove the water, and we throw it through that tube. Would it?
Well, as you can see from the experiments we do, the hydrolysis or electrolysis, whatever, it splits the water into its oxygen and hydrogen separately. And when it's put into an ionized state, they don't natively mix. That's why you see the green floating around the tube of purple.
Hmm.
And with a pink line all the way at the top because the nitrogen's the first to ionize and the most abundant, and that just happens immediately. The rest of it, it kind of it condenses down.
So
And then it goes into a diffuse state.
we need burning. Yeah, we would. If we wanted to break down the elements and put them in there in that state, what do you think about that? Now, you know how he breaks them down to the fundamentals? What if we put something like that as a core in there? So I don't think we've ever tried it. That's kind of the thing.
Yeah, I mean, so whatever has the most free hydrogen in its molecular structure, if you can isolate it from combusting, you're going to get a state that is going to give you the most energetic exchange, natively. So it'll just provide the least resistance.
By the way, for those of you who are in the material science of it, most of the free energy devices that come from the atmosphere have three separate materials in them. And barium titanate was one of them. And there's two other materials that I can't think of right now, but you'll find it when you start hearing about the experiments. They'll tell you it worked when he had this formula of mixture of material, and then it stopped working when he didn't. And there's a reason for that, and it's kind of the reason we're talking about the cores and how they're doing things. It's because they're pulling it in at a faster rate. Just like, okay, so when I did, and I'll bring this up again, okay, all recent. When I did Mike's Renegade, the light itself, okay, he has a little light that comes on there, a little neon, and it'll go green in there, and he says that's when you're getting the good energy out of it, right? But the piezo's themselves, they're both barium titanate, right? They don't act as like a drum. You'd think there'd be a sound or something weird, you know what I mean? Something like that pulsing. No, they're acting as a capacitor in the circuit. So what happens? The energy comes in faster and is expelled faster. It comes in faster the second one, expelled even faster coming out of the second one. Then it goes right to the light bulb. Why is it lighting up? Because it has a high enough peaks in it like this to continuously flash that big bulb, that LED, which it shouldn't be able to do. But that's why it's doing it.
Yeah,
It's interesting.
it really is. Now, hold on. Is it what you said about the liquid metals before? All right, there's super good points that you bring up, and why it's so effective, and why practically you're right. Okay, because what I'm talking about is a hyper, like you're to have those conditions is hard. But the reason that that is so important is because it lies in that phase difference, right? It's in the intermediate phase, right? So we know that there's a gas phase of it. We know that there's a solid phase of it that could exist, but it's in the intermediate phase in a liquid form. And well, what does that mean? That means that the molecules are free to move like they would somewhat in a gas, except they're at such a high density and in such a close relationship at that point that they could easily be induced into different structure, right?
Yes.
And it's that ability to have them fluid close enough to interact, not be wispy and wanting to go away because the relationship is not established. That relationship is established. It could be structured in ways that it wants to. It could be forced into structures, through certain other energy types that it could hold. And that's really, really significant because that means that you could virtually emulate a lot of different things that you want out of it that it may not be natively. And that could bring you right to the same place potentially as other things, maybe to a lesser extent, ideally, but functionally the same, with a lot less effort. So, like I just want to clarify that because it's a really phenomenal, um, thing that, you brought up there.
Well, we were looking at doing the end machine next. Okay, that's one of the next projects in line, and it uses mercury.
Mm,
Okay, as the pickup. So on both sides of the big magnet, you're going to put mercury on both sides. It's not going to touch or anything. It's going to be induced by the field, and then it's going to pick up the energy. That's kind of cool. You know what I mean? That's what we're going to see out of there.
mhm.
And I just want to shout out Courtney Sams. He's going to hook us up with the with the mercury, he's been saving it for quite a while, so he's going to take care of it, and we're going to be able to do it, and then we'll put it in the core. You know what I mean? See what
Mhm.
happens. We're going to put it on the outside, see the reactions to it, and a lot of people are going to see some weird stuff because the stuff that goes on in here is not exactly normal all the time. So, I'll put it in Tesla coil, everything. See exactly how it picks up, what the energy state is, if we can
Cool.
get amplification out of it.
Yeah.
Um,
I mean, just with the configurations that you typically run and stuff, you're going to get some really, really neat MHD effects off of it
oh yeah, yeah.
right away. Like, I mean, Mercury lends itself amazingly to that. It's nearly ideal. Hey, for what it's worth, I'll tell you what kind of irresponsible parents I had growing up. Um, my dad, he worked at a school and stuff, and they would break down science labs all the time, and basically like, all right, get rid of all this stuff, and we're bringing in all new stuff. Well, long and short, I mean, there was this one time that he brought me home. Actually, it was this one like a 1 liter size bottle this big, full of liquid mercury. I
Oh,
was, I was like maybe 12 or 13 years old. I wish I would have hung on to it. I don't know what the hell happened to it, to be completely honest
oh
with you.
yeah.
I mean, I used to do fun shit with it, like pour it into something, poke my finger into it, and I would amalgamate things into it, and then leave that separate because I didn't want to contaminate my main supply. I used to just sit there and like throw it up in the air like this because it was like it weighed so damn much, to the point where like it felt like it was pressurized
Hmm.
because it was literally bowing out on the plastic. I used to
Oh.
float rocks on top of it.
Hmm.
Like hopefully, well, I mean, anything that a typical 12-year-old would do with a, you know, I don't know what it weighed. It must have weighed like 15 pounds, 20 pounds. I don't know. Like it weighed a lot,
Wow.
but
Hey, real quick, I'm gonna grab that. I just want to show it off, real quick.
yeah, do it up. It's beautiful, by the way. I'm going to say it before you even show it.
So the wire's coming off the side for the battery. By the way, there you go. There you can see, man. Everything on there is nice and clean.
Yeah, man, looks great.
You can see the. Hold on, let's see it go the right direction. I color coded everything, so the schematic would be really easy to follow on how to exactly do this. And I just put it on this nice board, man. And then once this sucker gets going, it just spins like this all day. So and then this thing is just freaking yeah, a different light, dude. This light blinds me. So it's pretty strong, man. If it was constant, it'd just be like a regular light bulb in the room when you flick it with a light switch. It's that strong. So it's pretty
Really
cool.
cool.
So I gotta show this one too, guys. I've been working on this. This is some project I'm doing with Bernie. Um, this right here is my old man builds battery. So the dividers in there is basically you're gonna get orange slices in between them, and then you see the rectangles right there. They get filled in with copper on one, and then the next plate gets zinc. So it'll go copper, zinc all the way down. You can see the front of it. We got the negative and the positive in there, terminals. It came out beautiful, man. The lid, it's a simple little container. I think it cost me $5 for one of these over at the Target. And then I 3D printed the rest. And basically, what we'll be able to do is just figure out how batteries work and play with it a little bit. I kind
Yeah,
of,
that's stuff a Baghdad battery, man.
oh yeah, we want to see if the goal is 12 volts that's usable, just like a battery would be. If we can pull a usable voltage like that, I'm happy, man. That's kind of
Cool.
where we want to be. So yeah, enough for show and tell. I wanted to show those real quick, man, because we got some cool projects that I finally finished. So I think what I'm going to do, Joe, is just take one of them and run through the whole month with different experiments on them. You know what I mean? And just show it. And then next month, pick the next device and do it again. That way, they're already built and done, and I can just keep experimenting back and forth. I think that's going to be cool.
Nice. Well, I did an experiment this week.
What would you do?
So I was a little lazy. I don't have it on me. I should just show you, but I'll explain it. I was lazy and I didn't want to rebuild my Tesla coil circuit yet. Although I'm committed to actually doing that this weekend because I have a few tests that I've wanted to do on quartz for a while. So I'm gonna do that. Um, what I did was I took a pill bottle, okay, and I melted a hole inside the pill bottle to put an anode. Okay, and then I in the bottom put a hole to put a wire for a cathode. Okay, and then I put some water up in there with a piece of cork. Okay, that pretty much I put holes in the cork so it would have like wouldn't get super pressurized.
Mm-hmm.
And then on top of that, I put just an intermediate substrate. I don't know what it was, basically talc or something like that. It was just like solid talc, maybe. And I try to get a RAV to go on that by plugging those two wires into my base zapper Tesla coil. um, I've gotten a small RAV to form with that Tesla coil before.
Really?
Yeah. But I wanted to see if I could do it in this configuration where it was like more in this enclosed thing. I tried to get it to go, and I think the distances and just the way that the cathode energy was kind of being dispersed to the cork or whatever, it like wasn't really happening. Okay, but what was in, and it didn't even arc because like that's how I know that there was no relationship. You see, because it's like anything else. If it doesn't see the relationship, if it doesn't detect it's there, then it doesn't discharge at all. That's how that works, right? So I knew what the problem was, but be it as it may, I let it run to see if I could get the saturation levels up high enough. And while I did that, let it ran, I took like some wood skewers and stuff that I had been poking around inside of it with. And I was like, oh, let me just lay one of these on top. And then I would take the other one. Right now, what's interesting is when I took the other one and I laid it down, as soon as I got close to it, it would start drifting off like. And so now, check this out. When I brought it down and I touched it, right, it was going. It was literally drawing the tip of the skewer down and tapping it repeatedly against the other skewer. And I was like,
oh, really? That's cool.
I was like, it's an interesting field dynamic, that exists. And so it's not that it's like not creating a field, under those circumstances, but the field just wasn't arranged in the ratios and the exchange way that the RAV would come about or the arc would come about. But the fields and the magnetism that it created it was super strange in how it works because again, it's wood skewers, right? They're not conductive. That's what you use to knock somebody off the high power line with, but you don't get zapped to try and save their ass. Well, guess what? When you're dealing with these proper field geometries, they induce everything. So everything
can
just ends
charge
up
it.
getting in right. They enter into a charge state. Well, when you have something that's in the field but not through the same part of the field, and you introduce it in, all of a sudden there's a relationship, but it's an offset relationship. So it ends up having that sort of effect where it's like da, 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 da. And I thought it was super, super cool because you could like literally feel it going up and down. you know.
That
But
is
yeah,
cool.
it was an interesting thing. Was it worth me doing all that bullshit over? Absolutely not. I already knew that could happen, and I've seen it and observed it in other ways that are actually more fascinating. Just simply with rocks and no energy whatsoever, I could do that same type of effect. So
Nice.
whatever.
That's cool. Oh man. Yeah,
Yeah.
I was.
And speaking of rocks, by the way, I have um I have 7 digs that I purchased for the upcoming year at the mine.
Oh, very cool.
Yeah.
Yeah, I like the mining thing, man. I like it when you pull out the good ones.
That's what I'm hoping for. I'm hoping for some good ones. I want to get to the point where I have enough where I could start I could take a nice sample that's big enough and then drill into it and do some different things without me being like, I can't believe I just ruined this thing. Like so I need enough that at least I could do that without feeling guilty.
Yeah,
And then start sending it out, like I said, and everything. And I have a bunch still from I went digging last year. So
nice. Right on, Yanni. Stop for excuse me. Thank you for stopping by, brother. You said you had
yeah,
to
man,
go.
it's good seeing you. We'll catch you next week.
Right on, man. Oh yeah. Oh, Joe, I can tell you this right now, man. I had some problems with that whole coil on that Renegade. You know what it was? When you don't have it right, it doesn't do anything. So
That's frustrating.
yeah, it just
It doesn't
doesn't
even
do
give you a
anything.
sign as to what's wrong because it's not doing
Nothing.
anything.
It just doesn't do anything. Yeah.
Oh,
So I
that's
go, all right, well, let me hook it directly to the battery, right? So then you put a magnet to it, and then it does something, right? It pushes it away from one initial charge. Then you're going, man, this thing's supposed to go in and out, right? So here I am tracking down everything. And wouldn't you know it, in the middle of doing that, I dropped the wires and then they hit the other wire and then everything exploded in front of me. So there's this big smoke bomb that comes up in front of me and gassing me out, and all the wires are fried. And I'm like,
the
oh,
worst.
God.
The
I,
worst.
I spent 5 hours working on this thing, trying to look as neat and clean as possible. Oh, it was a disaster and a half, man. I'm like, oh my God. So then I made the video with the wires all burnt still, and I felt bad. I'm like, dude, I should have fixed them before that. But oh my God, there was like no signs of life in this thing forever. And I'm switching things around. And it has to do because Mike puts a spark gap in there in this little switch, and it's not normal to the system. So I bypass it, it works. I go to hook into it, it fails. And then it fails again. And I'm like, you son of a, you know what I mean? And I'm trying every different configuration of this thing. And finally, I got it halfway to work. And I'm like, all right, stay right there on that. Let me now use some jumper wires and try to figure this out. Complete and utter disaster. I felt like a blind man. I'm just like, dude, how the hell does this thing work? It's not going to work. And I'm just thinking, man, should I send Mike a message and tell him this thing is not working at all? What do I do, right? So then I just kept at it, and I go, finally, I got it to, start clicking. And he goes, it just started up immediately. I didn't have to do anything. I finally put the wire in the right spot. He goes, "Ooh."
That's it. Everything's got to be in the right place, or else it doesn't work. I mean, isn't that the way?
Oh yeah. Well, it was awesome. It was just one of the most awesome experiences. I'm like, yes, it's finally working, right? Because I'm over here moving the core all over the place, man. I'm moving the little sensor all over the place. I'm completely lost, man, and I didn't know what I was doing. You know what I mean? I'm tightening things, loosening things, taking out light bulbs, whatever. I mean, it was really frustrating. I took the core out of this thing, and then, by the way, the core didn't work perfectly right away. The little needles inside of it kept coming out and hitting the magnet. So then I go, okay, let me be a genius move. Let me glue the back of it, right, with some super glue. Well, yeah, it didn't perfectly work. So then I put some electrical tape on the front over the front of it, right? And that fixed the problem easy. And it slid right in there. And now the core works properly.
Nice.
So
Well,
yeah,
I mean, that's what this stuff is, man. Sometimes it's trial and error. But if there's anything that I know from doing projects over the years that have just been of my own conjuring or, art that I get involved in, it's, follow your intuition. Sometimes like you're like, I've done it the same way a bunch of times. I'm going to try something a little different this time to see if I can get some kind of result. Sometimes you're like halfway through and you're like, this is not doing what I wanted it to do. But like, you have this point where like you got to make a choice. Do you just abandon ship, or do you stick with it? And see it through to the end. And sometimes what I end up finding is that even when I think it's like I get flustered and confused in the middle, if you see it through to the end and just like take the little problems as they come, you step back, you look at the final result, and you're like, this is exactly how it was supposed to be and better than I had in my mind. And that's what's incredible about it. It's always that satisfaction, of seeing it through to the end. Because
Yeah.
anything you put a lot of work into, man, it is beyond frustrating when you're sitting there, just trying to get something to go your way and it doesn't. And unfortunately, sometimes things happen like that too. So,
Just want to shout out Ulysses out here. He gave 5 old man build memberships, man. Totally
right
awesome,
on, dude.
brother. Appreciate it, my friend. Yeah, I know what you mean, Joe, because I had a project just yesterday. Like, here's the thing. I got up and walked away from it, and it was a good thing that I did. Because, like, when things go wrong, I start stripping things down to bare parts. And
Hmm.
that's when I really get in trouble.
Oh, yeah.
But walking away for, a day and just get some logical thinking about it, that's usually what fixes it.
That's
Otherwise,
it,
I'm gonna
man.
have this thing in complete pieces.
Yeah, and being able to identify when that is the sign of maturity of you as a human being, because there are just simply times where you're like, feel like that. And if you just keep going, you are about to ruin it. But simply just a fresh mind will give you a whole new look on it. Sometimes you got to put stuff down for a while.
Yeah,
Sometimes you got to put it down and just simply walk away and have it sit there. And then one day, when you're not thinking about it at all, you're going to be like, wait a second. Ah, I think I just figured it out. And then you go and you try, and it's like, wow, see, this is cool. Well, guess what? If you would have just kept your path, you'd have messed it all up and given up on it and forgotten about it.
yeah. Well,
So,
I had 2 3D printers that were broken, and both of them had the same problem. So I had a thermistor break. So it's just the little thermostat that sits in the head of the printer, right?
mhm.
And I looked at it and I look, it was all black, and I go, well, I know it's burnt. You know what I mean? But here I am going through things and I hitting the buttons on the little face of the thing, and it says it won't even go to it. And I'm like, oh man, do I have to go back and do all the software again on this? Do I need to go back through it and work on it because it won't preheat the PLA? And it's something stupid. It's a $10 part, and I know exactly what it is, right? And I've had the problem before, and I was just so frustrated that day. And then I go, oh well, let me just get smart, and I'll take another 3D printer apart, and I'll use it, right? Then I broke that one, and I'm like just compounding the whole problem. And I just finally walked away, and in the end, it's like $50 of the parts, and I have them both fixed. And I'm just like internally frustrated with myself. Is really what it came down to.
Yeah, well, especially stuff like that, because not only does it take you time, and it takes your money and it takes your thought away from what you're doing, but it's downtime away from what you're doing, both
Yes.
because it's non-operational and because now you're sitting there trying to figure it out, and that's the worst kind of problem to have. But you know, and the ones that turn the most frustrating the fastest, for that exact reason. But
Yeah, I'm there with you, man. Yeah, well, thankfully I got that thing, on the mend and getting fixed. But I think I'm gonna buy a whole new printer in coming up. I wanted to upgrade all my prints to come out for when I sell my coils, so I'm gonna go ahead and buy a new one. So
right on. I want to give a shout out to my buddy Mitchell Frederick out in the chat. He's a very long time friend of mine.
nice.
Just appreciate him tuning in. It's good to see you out there, and welcome to the membership. Go check out the plasma experiments we got going on, man, because you're really gonna like that stuff.
Absolutely. Just shout out Traveling Fools right now, man. We're gonna have a person who won the first on the show alone. He won the competition basically where they all go out there in the middle of an island somewhere, and they all try to outlast everyone else. Well, he was the first one to do it, so he's going to be on the program tonight, man. It's going to be a really interesting interview. That's going to be cool.
Yeah, that is very cool. I'll have to see if I can check that out. If not tonight, then I'll catch it tomorrow.
Yeah.
Oh, actually, interesting. I don't want to call it a conversation, but I saw that good old Ashton Forbes had Sal Pais on again, and he's had him on a bunch of times. And I like whenever he comes on. I find him to be just like, kind of like one
He's
of
an
us.
interesting guy, yeah.
Yeah, he's a smart guy. He's an interesting guy, and he's definitely one of those guys that just can kick back in a garage, with a fridge and just put him back and curse. You know what I mean? I love that. So I actually found his email address. I shot him an email. I sent him my paper and a couple of pictures of the Rav. And I was like, hey, I'd be interested in talking to you about what you think about this. Whatever.
Nice.
He looked at he looked at the stuff and got back to me. He's like, I can't talk about this. He's like, I can't talk about this.
Oh, well, that's probably a good thing, huh?
But he said it very nicely and respectfully, and he's like, with the kind of a nod and a wink, and he was like, I can't talk about this.
Nice.
Yeah. So sometimes, that's all you need to hear.
Yeah.
That's all you need to hear.
Well, yeah, from the military. No matter if you're in or out, you're always in. So yeah, you'd be in a lot of trouble. Which
Yeah.
means we're in the right path.
Yeah. Well, and that's the thing is, it's like he said, and he explicitly said, he said, other than what's already been publicly discussed, he's like, I can't. What is it? What is that email told you? You see? That's all. That's what the email told you. It told you that Sal's a patriot and listens to his command. Okay, because he straight up said, he said, superiors say no. But he also said that I can't talk about things that I have not already talked about. And he's like, and I can't touch this.
Basically,
That's all you need to hear.
Yeah.
Okay, so you can go on Ashton Forbes and you can talk that stuff all day, but don't talk about this stuff. Well, he can't. We can because we're not bound by that. But that's all I needed to hear. Thank you, and I'm a big fan of his, so that's very flattering. And it's just nice to even know that I was able to, get a response from him. So,
well, just so everybody knows, man, I'm presenting at Tesla Tech this year, and I'm going to be presenting on field coupling. So we have some experiments to show out there, and it's going to be awesome. So, yeah, in September, man, we're going to be out there in New Mexico and showing it off, and finally get people to understand that all this brute force and 2 million amps to lift something off the ground and all that stuff doesn't work, and we're going to show them how it properly works. So I guess Sal Paez would be hiding, not wanting to get in that conversation. But we're going to show it.
The last thing he said in the email was, he's like, just always keep one thing in mind, that simple is good.
Yeah.
That's what he said. Simple is good.
Yeah.
So, yep. If he ever tunes into this, thank you for the response. You made my day. You made my week. Much appreciated.
Very cool. Well, I'm glad he did, man. That was awesome of him to get back with you.
Yeah, I thought that was really cool. Yeah. Still would love to have had him on as a guest. I think that would have been ultimate, but
Well, maybe bring a different topic to him, you know what I mean? Than that. Maybe just go right into what he's working on, you know what I mean? And see if he wants to come on for that. I'm sure he would like to just come on and say his spiel, you know what I mean?
Yeah, maybe.
Never know.
I think he's got a good thing going for him, what he's doing. I think that's a good comfort. That's a good comfort zone where he's at. And you know what? Again, I just appreciated the response. I've been a fan of his stuff for a bit, his appearances and the like.
Yeah, well, I'm there with you, Joe. I,
Yeah,
I,
no.
I like listening to him as well. And I like Ashton too.
Yeah, no.
So,
Ashton's a good guy too. It's
yeah.
you know,
I just like the fact that he pulls out all the physics, man. You know what I mean, from everywhere that not many people ever look at. It's like collecting dust, and he's finding it. So that's one of his parts of his program I really enjoy.
right on. Uh, I guess before he brings it up, then I will. I mean, I'm not saying we should do what he does and show it, but that video I sent you, I know you didn't have the best takeaway from
Oh,
it, but there was recently, you know, an EM gravity video that was released. Forget the gentleman's name, but nonetheless, it was only released about 2 days ago. And a lot of the stuff that he brought up, how he talked about it, the way that he went about it, it literally evolved just the same exact way that I personally choose to have chosen to explain it, with direct correlation to the physics paper that I wrote on energy exchange, dimensional energy exchange, time and gravity. So I thought that that was super interesting. One thing I will say is that my takeaway from it was that it was all good information, but even though he says, "Oh, I got green lighted to show, to say what the experiments were and etc."
mhm.
There were a couple of fundamental pieces that I believe were purposely left out. I believe they were purposely left out. Nathan thinks he just doesn't know. It doesn't really matter whether he doesn't know where he left it out. The fact is that there's at least one major component missing from it, in my opinion. Um, but yeah, definitely check that video out because uh again, he says everything that I say, except he doesn't get word salady and like flustered and confused because he's been a plasma physicist PhD for 50 years. So
Well, there you go. I went to put the link in the description in case anybody wanted to watch it. He did present the same thing on APAC a while back.
it was on APEC. I think it was
Yeah,
originally.
no, it
Mhm.
was. I saw him on there. I saw him when he did his original presentation.
Yep.
Yeah, just so everybody knows, the problem I have with it is, how do you beat to gravity if you can't properly define what it is? That's the hard thing. I mean, what do you know that you're canceling? And if it's just a mathematical equation where you put in big G or little g, that to me is a complete failure. It You got to know the components of it in order to beat it, is my opinion. Okay, so you can shine over that if you want to, but as someone who builds things, I just can't. So that was my big thing with it, not so much everything else.
Yeah, I mean, I felt like, at least in the theoretical sense of things, because the engineering can be there to meet these theories. It's not anything impossible because, frankly, it actually coincides directly with the RAV. But the reason that I felt like it had really, really good credibility was because he brought in the E times B drift component of it, and how that deals with the helicity and directly correlates that to an upper dimensional relationship that exists, where it's a direct connection. It's the same exact thing that I've been talking about. Direct connection, upper dimensional mechanism that runs the whole entire thing. And then the examples he gave were good because it shows all the proper field geometries, flow patterns. Okay. Even goes as far as saying that it's eddy currents that realistically drive the objective mechanism, without going further and further down that rabbit hole, right? But the big thing that he left out was the energy density levels and how you get those energy density levels, how you need them, because the input amounts were small. So all of his, results were small and proportional to the energy input. So, in my opinion, the missing part of that was had everything to do with resonance. Because he's not, if you don't have the system in resonance, you have losses. Then you're subject to just simply the effect of your input power, right? But if you have resonance, you have a building power, an amplifying power, one that
Hmm.
starts to fall into capacitance states, right? And that's how you get your energy density levels much, much higher without a higher input level necessarily. So by slightly increasing, your initial voltage input and then putting your system into resonance, technically it should actually have a much more significant effect. Now, whether or not you get it to the point where the thing's floating off the table or not, I mean, you could have that argument in your own mind, experiment or build it, right? But I'm a proponent of believing that that actually does significantly work. And I think that that's the same type of inertial mass reduction that they were using in aviation for the last 55, 60 years. So
The, well, once you realize you're playing in the gas state in anti-gravity, then you're going to start to get the right answer. But you got to realize that and why that's true. Plasma comes after that state. If you don't understand the compression of gas and why it's working, I mean, it's no different than a hot air balloon. You're compressing gas in one way or another. You know what I mean? You got some kind of helium going on. You're compressing helium. There's inventors out there that took just balloons and they're wrapping wire around them and they're getting an anti-gravitational effect when it comes to initial mass reduction. Why? Because they're compressing it and they're distorting the field and the gas on the inside of it. That's exactly why. Once you realize that, then anti-gravity becomes a little easier. It's more of a challenge of how do I make something work in the environment that does that? Well, see, that's why the RAV's so important because it
mhm.
works in the environment. You're coupling the gas, you're making it work. That's why we're studying it. That's why it's so special. We already realized this point. I mean, think about anything that lifts. What are you doing? You're pressurizing gas around it. You don't think of air that way, but what is air? Air is gas. It's a gas in the environment. And you're just creating pressure gradients around it. So I don't care if that's a wing of a plane. I don't care if it's a hot air balloon. I don't care what the heck you say it is. That's all you're doing. So once you understand that you're in that gas state, you can understand, oh, well, if I make a rotation around it, I can get harmonics. I can make it to move smoother. I can get it to sound better. I can get it to flow better. I can get that laminar flow in between each one and make it go faster. Well, now you're in the right mind of thinking, okay?
Yep.
Instead of let me just throw a bunch of energy in it or magnetism at it. Well, no, that's not what the world's telling you. It's telling you're compressing gas, and how you compress the gas with energy is how it matters. So
Well,
just
right. I mean, at the end of the day, if you were to take just the RAV configuration
uh,
and you were to, um, put it basically where the top of your the craft, right, were an anode, and the bottom of your craft were a cathode, and then you have an intermedium reaction, the RAV reaction, intermedium and isolated. Well, you would have the same exact field geometries that are occurring top and bottom with the same exchange. And those are the exact conditions that are required for anti-gravity, the exact conditions. It's the exact same exchange. And what you notice is that it's one side is an eddy current with a center cross exchange. The other side is an eddy current with a center cross exchange that acts as the new center of gravity in your cross exchange. And
but that's
that's the thing about it. It's like, I mean, you can either see it or you don't. I don't know.
it's an energy state controlling a gaseous state.
Yep.
But that's what it is. I mean, you have to understand that. That's a
Right.
fundamental part.
Well, but
It's
we've
all
seen,
energy.
right, right. But we say the gas state, but at the end of the day, here's what we know. We know that we can move plasma through different density phases, right? And we've seen wispy, gaseous plasma, and then we know what it's like to sit there and pull plasma into a fluid state, right? We see that fluid state in almost every experiment that we do once the density levels get high enough, where it stops acting like a wispy gas and starts acting more hydrodynamically, right? But we also have seen multiple, though more rare, examples of plasma acting like a solid. And like, and that is good example when the fractal snow emerges, and you realize that if it's the type that doesn't stick around and accumulate because it's not crystallized in that way, right, and it poops away to nothing. Well, yeah, that's because it was a virtual solid of what? Charged particles. Well, what the hell are those charged and ionized particles? Plasma in a solid looking state because it's an acting like a solid. You see, and that's it. The plasma moves through phases too. So, when you create these different densities of the plasma, you think it interacts with the environment differently? Hell yeah, it does. The same as material does,
Mm-hmm.
just in the inverse way, right? So it's all very interesting to start to think about because you start to realize, oh, all the things we know actually apply here at a very basic level, but making that connection, it takes a little bit of thinking outside the box, trusting what you see and not what you've been told.
Well, once you realize that radiation messes with the gases in the air, and that's the exact reason why it's building the field. Now you want to amplify that, you need the impulse of the radiation, which is the negative side of the radiation, in that in order to control it. But it works the same in water. When you structure water or destructure water, you're putting radiation into it. That's why I say when you look at Maxwell's equations, he's missing radiation. It's a fundamental factor that's always there. It just goes dormant when you have low energy, but when you get into a high energy state that's compressed, it shows up all day long. So, but that's exactly what we're dealing with in here. You don't think that that balloon's getting off of radiation? I can see it as soon as it gets in the air. You could see it. You know what I mean? You
Right
start to
on.
see it messing with the air and the environment immediately, which means it's playing with the gas in order to structure the field around it. It it's not
Yeah.
that hard to figure out. That thing
And
is, yeah.
metaphysically, right? When you're able to actually bring yourself into greater ambient vibration, you're able to kind of, melt into, that what you're subject to. Well, in those states, if you like focus and you look around, you'll start to see all sorts of different, they'll just write them off as optical effects. You know what I mean? Oh, well, yeah, but those are optical effects. So no, you see, when you become very still, okay, and you become part of the ambience, any sort of disturbance that falls outside of that spectrum, stuff that you would normally never ever experience because you're just at a different rate than the ambient environment, right?
Hmm.
As you start to see it, it starts to become apparent. And when you're in these fields like Nathan builds, right? Well, you're inside of the energy field and you're holding that same energy and you're falling into that new ambient environment very fluidly because it's a high charge state. And all of a sudden, all of these things that are actually there, that maybe you wouldn't see otherwise. And I'm not, when I say things, they're not real things, by the way, but you start to see them, you could start to see kind of the flow of the energy around you, air through, like, it's not obvious. It's not like, dust or smoke in the wind or something obvious, but you start to see little differences, and it has a bias and a direction and a thing it's doing or whatever, like it's there.
That's going to surprise a lot of people. So when Lightspeed comes out with all those sensors and stuff, you're going to see what I finally see. You're going to start to see the fields built around this gravity flyer. Then everybody will start to understand exactly what I told them. You know what I mean? It's all there. It's all always been there. So anyway, I find it interesting. We're about to start to see things in a whole different light this year, and I'm hoping that whole thing comes together, man, before I get to Tesla Tech. because I just want to.
I'm hoping, and you know what, it would be great that it would, because that would take it from an interesting talking point that makes a lot of sense and was entertaining and whatever, to groundbreaking. Like there's no dispute any longer, and that's, I think that, again, these people that haven't fallen, I don't want to say in line, that's not right, but haven't like accepted this type of work just because of who we are or how it's done or whatever, or it doesn't align with what they already have decided. It takes a lot for them, to be convinced otherwise. They're the type of people that, see the effect that they were looking for and say, where's the trick? Where's the string? Or whatever, and it's like, no, no, no. But if you get most people the data and the experiments and the repeatability and the falsifiability and all the stuff that they generally expect, I mean, they'd be a lot more open to being like, wait a second, there's something here, you know? And that's what I'm hoping. I think that's what it's going to show.
Well, yeah, what a place to do it, huh? Get on one of the grand stages of them all and give it to them. You know what I mean?
You're definitely in good company. I saw the proposed, schedule there.
Mm-hmm.
And there's definitely some good and interesting company. What I will say though is that, as super cool as it all is, if you come with receipts to that, like we're talking about right now,
Yeah.
there is nobody there that has anything up on you. Nobody, because all they're going to talk about and all they're going to show is the speculation of what you're going to bring receipts for. And
Yeah.
that's amazing. And that's not a down, it's not pulling, like there is brilliant people going to that. But I saw the list. I know what they talk about. I know what they do, most of them, and it's great stuff. The thing is, it's great stuff because I know and I believe that. And that's the category I fall into. If I was a skeptic, though, yeah, that's how I'd feel, right? Well, you bring the receipts, and you'll be the only one that did.
No, bring
So
the receipts and then have the discussions that need to happen. You know what I mean?
that's it.
So, anyway, all right, guys, it's been about 2 hours, man. I just want to give a shout out here, man. Darren hooked us up, man, with a $10 super sticker, man. Very awesome. Lightspeed 5 Old Man Build memberships, man. You're totally awesome, man. Can't wait till that project hits my door, man. I'll meet up with you in person. We'll figure that out. Ulysses 5 Old Man Build membership, man. You're awesome, brother. I really do appreciate it, man. You guys are all awesome, taking care of the show, man. Keeping us going, keeping projects going, man. We got a lot of stuff coming out here in the next few months. Plasma Unleashed is going to be releasing on this next Monday, so be
Yep.
ready for that. And then we're going to try to get that every week. We're going to work a little harder on it. Also, I'm going to start releasing the stuff I did on the Bedini, so you guys be able to see it, the build and everything, and then what things I did. We got the Renegade going. I got the battery cell working. Those are three things, man. They're definite projects that are already like right there on completion, that are ready to be shown. And then we have an end machine that we're building. I have all the parts for it. I just haven't gotten this time to sit down and do the STL files for it. But it's pretty straightforward. It's basically what is it, a monopole motor, and we're using mercury as a pickup on it. So that's going to be pretty special, man. I'm
That
excited
that
for
is,
that.
man. You've got some great projects going on and coming up, and the way that Nathan's doing it, in my opinion, is the best possible way. It's taking the same type of way that we're approaching the RAV, but approaching all of these different, experiments that have been done in the past that have been a little occulted, and showing it and bringing it out for exactly what there is. So it's not swept under a rug anymore, and you could take it from the man that built it as to exactly what's going on and what he's getting out of it. Now, I know we're wrapping up. I do want to address one thing
Go
that
for
was
it.
in the chat just real quick, and it was for Mark. He said, what is plasma to ether? John Bigman said that they're the same. Okay, but I want to chime in on that real quick. And not make a big thing of it. But in my opinion, okay, plasma is not the same thing as ether. Okay, in my opinion, it is an intermediate state. Okay, between the ether, meaning on the other side of the ether, because I'm defining the ether not as the dimension beyond, okay, but rather as the threshold, okay, the pressure boundary that exists dimensionally, okay, which is where time emerges and all that sort of stuff. So basically, it's the same thing as space time. In the traditional GR sense, I just don't subscribe to that way of thinking, even though it's not wrong. It's just a different definition. I digress. Plasma, in my opinion, is the intermediate state, okay, which can become transient between dimensions in the similar form, okay, because it's a matter-like energy, okay, whereas an opposite that also fits the same bill, and I've said this in the past, is hydrogen, right? Which is a matter. No, hydrogen is a matter like energy. Plasma is an energy like matter. I don't know. I think I'm screwing this up, and it's late, and I've worked all day. You get what I'm saying? The whole point is that it's a transient phase. Okay, where it's basically energy coming over from the ether, okay, and trying to take matter back to it in an energy state, high state of excitation. The whole name of this game, the whole reason that time, space, matter, all this shit exists, is this whole idea that energy is trying to do away with matter, but matter is trying to capture energy. This is the exchange. That is the exchange. So in order for it to dimensionally be able to bring matter back into to the energy state, it needs to become highly charged enough, which I said earlier in this episode, right? It's sucked in, but it only sucked in the matter because it was in a high charge state. That's exactly the point. It's the intermedium that can exist both here and there. And that's to me what it is. It is not directly ether. It's just energy trying to take matter back into the etheric state. That's just an opinion, but hopefully, that kind of clears up my 2 cents about it.
Right on, brother. Right
on.
Yep. All right, guys. Have a great night, man. I'll see you guys later on Faraday Research tonight, and then also on Traveling Fools. Have a great night, everybody.
Very good. Peace and love.
The old man real. The old man real. The old man real. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. of destiny are spinning in his mind, making him travel back and forth in time. Battling the establishment for just a little recognition has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds